Welcome to Unit 4, Lesson 10, a new kind of number. Let's invent a new number. Okay, so what we have here is a new number system. The complex numbers. Now, you've all heard of the real number system, which includes rational numbers, integers, whole numbers, natural, and irrational numbers. These are all subgroups of real numbers. Now, the complex number system, the new number system we talk about, are imaginary numbers and complex numbers, which is a real number plus an imaginary number. So again, a complex number has a real part and an imaginary part. And I is equal to the square root of -1. We can't take even roots of negative numbers. We can take odd roots. So if this index had an odd number here, like a 3 or a 5 or a 7, we could do that. But with even roots, we can't do that. Now, we're going to run through this in a little bit, and I'm going to show you a diagram. But I1, I squared, or I to the first power, I squared, I cubed, I to the fourth, and so on and so forth, they follow a pattern that we're going to learn in a little bit. Okay, so let's look at the first problem. Numbers are inventions. Numbers are made up. Jada was helping her cousin with his math homework. 8 plus some number is 5. And we all know that 8 plus 3 equals 5. But if you was to solve this mathematically, algebraically, if we subtract 8, x will equal -3. But you can't have -3 grapes. So this, if you do it with real objects, it doesn't make any sense. But you were supposed to come up with an explanation to make it make sense. Okay, now, for the better part of your life, you've been dealing with the real number system on a real number line. So all real numbers, and all real numbers includes all decimals. Okay, so the equation x squared equals 9 has two real solutions. So how do we solve when something is squared? Well, we take the square root. The square root gets rid of a square. We're left with x. The square root of 9 is 3 and -3. So 3 and -3. Now, if we drew this on a graph of y equals x squared, that's this graph. 9 would be here, and 3 would be here, and -3 would be here. And what you're supposed to do is draw a line over till you hit the graph, and then come down and you hit 3. And also, it hits 3. That's what they mean. We did that a couple lessons ago. So that is the answer to this one. If this is the x-axis and this is the y-axis. Okay, how many real solutions does x squared equal 0 have? So if we use the square root of 0 is 0. So it just has 1. And now, how many real solutions does x squared equals -1 have? Well, when we take the square root of that, x is equal to the square root of -1. There are no real solutions because if you draw a parabola at y equals x squared and you're at -1, it does not touch the graph. So there are no real solutions. This is why there is no real solutions. No real solutions. Now, what we introduced you to in the beginning of this was an imaginary number. An imaginary number, like I, is equal to the square root of -1. An even root of a negative number is imaginary. So for most parts, we're going to be dealing with the square root of -1. So now, on a real number line, draw an arrow starting at 0 that represents 3. So 0 that represents 3 goes right there. And then 1 that represents -5 will go to here, because 3 and 5 are right there. So that's -5, and that's +3. Now this diagram shows an arrow that represents -1. So this right here is not an XY coordinates. This is a real, and this axis right here is imaginary, to help you understand how real numbers work. They work just like numbers, but they're not real. Now, let's look at some other numbers that are imaginary. So draw an arrow starting at 0 that represents 3 square root of -1. So 1, 2, 3 is right there. So that would be right there. That's 3 square root -1. Draw an arrow starting at 0 that represents negative square root of 1, which is right there. And then draw an arrow starting that represents -5, -1. So we would have to come down to 1, 2, 3, 4, 5, and come down here. And this is -5 root -1. And this one is 1, -1 root -1.